Hi, what's up? I'm Jux and welcome to Layman's Guide to Cracking the Coding Interview. Today we'll be solving one of the fundamental sorting algorithm, and it's one of the fastest sorting algorithms that we often see it in the Java libraries, and it's quicksort. So I'm going to go through the code and I'm going to explain in details. So before we jump, I'm just going to explain quickly of one iterations, then I'll write the code and I'll explain that. So let's take a look at this example. So we have numbers, so we need to do the sorting, and we need to pick a pivot in the quicksort. So in this case, I'm picking a midpoint as a pivot, but there are several ways to do that. Some have they pick the 0 as a pivot value, or some pick as a nth value as a pivot. But in this case, I'll pick 5, and there are tons of resources that you could explore which one is the best. And for me, I think picking a mid would be the best. So in this case, we have this numbers, and I'm taking the mid as the pivot value. So then we have the pointer L and the R, and we compare if value of L is bigger than pivot value. So here it's not, so we increment, and we are here at 2. So we check, is it bigger than 5? No, 2 is still smaller, so we increment the L. So now we are here. So we check if 5 is smaller than 6. It is. So now we go to the right hand side. So now we check whether 9 is smaller than 5. It's not, so we decrement the value. So now we are here. So now is it smaller? Yeah, it is. So when it's smaller, we swap the value. So 3 goes here, 6 goes here. Right here it's been sorted. So now we again increment the L, decrement the R. So once we hit to this point, then we have a partition where all the left hand side is smaller than 5 and all the right hand side is bigger than 5. So we have a partition. It's more like a divide, but this is not exactly the divide and conquer rules. We have a merge sort that does a divide and conquer. Here it's just a division, but it will be sorted automatically. It will be in place sorting, however. So let's jump into the code and I'll write it and explain it exactly what I just described. So I'm using this as my IDE. This is not the IDE, this is a notepad. So let me define the function. Then I have a parameter as given. So in reality, we'll have a min as a 0 and the max as the length of the array minus 1. So for me, I'll just put it min and max, because we're going to be passing through from the main function. So this is our statement. So then we need to check the base case. So if the given is none or length of given is 0, we just return false. We have this, and we need to check if, because min has to be smaller than the max. So if min is greater than the max, which shouldn't be, so that's why it's a base case. In that scenario, we return false as well. So we have defined the base case. Now we need to pick the midpoint. So midpoint would be the min plus max difference of this by 2, because we're using this to have integers, else we're going to have a floating point. We don't want that. We want the integers as a midpoint because we're talking with the index. That's why. So as I told, I'll pick the pivot as a given, and I'll put the midpoint. So once we have that, we need to make a comparison. But first we need to, as I mentioned, we need to go through this. Go through if while. But before I do that, let me put this I as a min and then j as a max. We need this because min and the max would be changing, so I'll define it as a j and I and j. So while I should always be the less than j, we should be iterating, right? So in that case, as I mentioned earlier, while we have a index of I, if index of I is smaller than the pivot, then as I said earlier, we're going to be incrementing the value of I. So just put 1, and now we're going to be using the right hand side. The above was the left hand side, this would be the right. So the given j is greater than pivot, we're going to be decrementing j, so that would be 1. So if the condition matches, then we do the swapping, right? And also we need to make sure we are on the good path, else we are not. So in this situation, we do the swapping. So I'll just do the swapping right here. I don't want to create a different function. So given j and would be given I. Given is an array, by the way. Hope it's clear. And then we have a given I would be the temp value. So we did the swapping. So whenever we hit these conditions, if the pivot, if the given is greater than the pivot in terms of left hand side, I is the left and the j is the right, right? So in that situation, we're going to do the swapping as I showed you in the pictures earlier. And also at that case, we need to increment the value of I and we need to decrement the value of j. And after we do the swapping, we'll keep doing the swapping. And after we finish this condition, if I hits to the j as we saw in the pictures earlier, then at that point we need to change the value of I and j. So if min is greater than j, in that case we call this quick sort. It should be sort. Oh, there was some small typo. Let me fix this. Alright, so we still pass the same array, and then we have a min, because this is on the right hand side and other one would be on the left hand side. So I'll start with the min and then I'll go up to j. So this is the right hand side and our left would be max is higher than I in this case. Then we call quicksort and the given, and we have a I and then we have a max. Hope this is clear, because after we finish this thing, we are partitioning this. So this will partition the left hand side, this will partition the right hand side. We do have that. So this process continues until we hit the base cases, and by then our elements in the array would be sorted. So by then we just return the value of given, so it will be in place, so there's no extra need of the memory space. Let me take this just to check. 5 4 3 6 7 2 8 1 and 9. Oops, where did I type? Let me cut this and paste right here. So when let me 0 1, I think the base would be I put it in the ID and then I run this. And let me just paste this in my ID so that I can run and I can show you this. Let me copy. Okay, let me paste and I create an example and I create a main functions. All right, so we do have it here, and I would just copy the example as well. Where's the previous example? Let me copy this here, and I'm gonna paste here. So we need to see the output, so I call the function, and I'll just pass the given 0 and the length of the given -1, right? And then I'm gonna print the value of result. It should be sorted. Right now it's 4 3 6 7 2 8 1 9. It's really random, I know. So hope it's gonna be sorted. Let me run. All right, yeah, we do have it right at the sorted thing. So we have 1 2 3 4 5 6 7 and 9. Exactly. I took this example and it working perfectly. So what I did was I checked the base case. I have a midpoint here. In the previous example, the midpoint was 5. So here it's gonna be 7, and then that's the pivot, and then I have an ij, and then I run the condition. So yeah, I run the condition, and every time if this is not, we just increment the left hand side, and then I decrement the right hand side if this is not. If we found both the value, then we do the swapping, and after we finish doing swapping, then we we have a partition now. Except the midpoint, we have a left partition, we have a right partition, and we do the same thing. The midpoint would be this value. I mean, here the half would be sorted and half would be sorted. In a sense, like 7, everything less than 7 would be on the right hand side. Everything greater than 7 would be on the, oops, I messed this up, on the right hand side. And then that will be sorted. Let me take some random example. Let me look at some example. Okay, I'm just gonna use a random example. So this is 9 1 2 8. Okay, so this should also be sorted, right? We have a sorted thing. I still have some doubt. Let me put 1 at the end. What's gonna be, because I'm not sure whether this can run or no, because we need to check all the cases. All right, I think now I'm sure that this algorithm is perfectly nice and it's working fine. So yeah, we have the quick sort algorithms, and let's do the runtime analysis now. So in this picture, in this figure, we have n numbers of items. So the runtime would be obviously on, and plus it goes through every tree. Like we have we're gonna be having the half of this, we're gonna have another half of this. So it will follow the binary tree. So the runtime obviously would be n log n. So let me just write it here. It's gonna be big O of n, because we are iterating through all the items and we are moving across the height of the tree. So that's it. So this is gonna be the runtime for this algorithm. Thank you.